Welcome to my presentation. In this presentation, let us look at some examples related to eigenvalue and eigenvectors. In this, let us take an example. In this example, let A be the given matrix, and the elements of this matrix are 1, 4, 2, and 3. And then let us say we have a vector x given as 1 and 1. Okay, we want to find the eigenvalues of matrix A corresponding to the vector x. So to solve this, we're going to follow the following steps. Step number 1. According to the definition of eigenvalue and eigenvectors, we have seen that we can define it as Ax is equal to lambda x, where lambda is the eigenvalue and the x's here are the eigenvectors. So we will take the left hand side of the expression and then try to show that and then try to find the product of the matrix and then see whether we can arrive at an eigenvalue and then the corresponding eigenvector, which is the given eigenvector. So we will see that. So if I were to take the left hand side, which is Ax, A is a matrix given to us, which is 1, 4, 2, and 3, and the vector x is given to us as 1 and 1. So we're going to use our matrix multiplication method to simplify this, and to do that, we're going to see if the multiplication is possible. For matrix A is a 2 by 2 matrix, and the matrix x is a 2 by 1 matrix, isn't it? We have 2 rows and 1 column, and then as long as the columns are equal to the rows, we can then come back and then say the final matrix is going to be a 2 by 1 matrix. We have seen that in my matrix presentation videos. So let us expand this. So the way we can expand this is as follows. We take the row of the first matrix and then multiply to the column of the second matrix. 1 times 1 plus 4 times 1, that is the first row, first column of the product matrix. And then we take the second row and do the same thing. And then when we do that, it is going to be 2 times 1 plus 3 times 1. So when we simplify this, this is going to come out as 1 plus 4 and then 2 plus 3. When we simplify this some more, it is going to be 5 and 5. So if we were to pull out 5 as common, we can also write this one as 1 and 1. So 5 times 1 is 5, 5 times 1 is 5, therefore we can pull out 5 as a common here, and therefore we can make some observations from here. In here, this 5 is what is called the eigenvalue. Eigenvalue lambda, that is equal to 5. And then in here, this 1 and 1, this is called the eigenvector. Let me write it a little bit more clear. This is called the eigenvector. And the eigenvector, this is the given vector, isn't it? 1 and 1 was the given vector to start with. That is what we have here. That is the vector we started with. So we have shown that when we have a matrix and when we multiply by the given matrix, we were able to arrive at the product, and then in that product we had the eigenvalue embedded in it. So this is a very simple example, but this nevertheless illustrates the point to find to be able to find the eigenvalue for the corresponding eigenvector. In my next presentation, we shall look at some more examples related to eigenvalue and eigenvectors.